Good afternoon. Thank you, Alexei, for the ability to speak at this conference. It's already the second conference on RWD, RWE. Well, as for my history, well, I am a doctor, I'm a cardiologist, but I've been dealing with clinical trials and pharmacovigilance over the last 10 years. I've been working at the IT area, and I am in charge of Flex Databases. I am Flex Databases CEO. I'm going to talk about medicine and IT technologies. Obviously, when we talk about the RWD, RWE, well, it's impossible to talk about all these issues without the digitalization of medicine and the development of IT technologies. The goal of my purpose is to bring to the medical audience those concepts which are being used at our conference, technical concepts that we use, and to show their importance. Let me start with definitions. My colleagues from other technological companies, and I noticed doctors in particular, Mikhail Samsonov was one of them, mentioned all these definitions. Let me just draw your attention to the fact that what stands behind those terms. What is data lake? Well, data lake is easy to understand if we look at Lake Baikal. Lake Baikal is unique to 197 rivers and streams fall into Baikal, but only one river, the Angara, flows out of Lake Baikal. The same is true of Data Lake. Well, so it's like Lake Baikal that gets water from different sources, and data lake gets data from different sources. So these are rough data. As for IT technologies, they allow to structure those data and to make specific conclusions. So now we have the processed structural flow of data, like the Angara flowing out of Lake Baikal. You can bottle this water, you can store this water on the shelf. So now we have data warehouse where all the data are being stored. So the data are already structural and they have been processed. The next term relates to what we are going to do next to those data. Data are going to be processed, and it looks like this is a complex process, but in fact, these manipulations are quite understandable. We do data anonymization. We know that there is federal law 152. We know about HIPAA in the United States on the protection of personal data, on GDPR, which entered into force in the European Union, and this law also led to changes, drastic changes in the field of medicine and clinical trials. China, starting from October 2021, adopts a new law on the protection of personal data. So the world is moving into this direction. So in order to process big data, unstructured data, this data must be anonymized according to the existing legislation. That means, well, we have no personal data. What is personal data? Well, each law has its own definition, so you should know the situation with each particular country to do the anonymization. The next step is data normalization. Some of my colleagues have already mentioned that, so data should be more or less equal. So if, for example, there is some redundancy in data, in this case, this redundancy can lead to a bias. That is why analysts are doing their work, so they remove redundancy, data become normal. First of all, wrong data will be deleted. For example, if we see the negative age, like a person can not be minus 60 years of age or something like that. This data should be deleted, and the data in this case will be right. This is necessary to do in order to avoid any mistakes with conclusions, because all this information from data lake can be sometimes wrong, incomplete, and we need to work with them. There is also another important step, which is data standardization. In order to process big data, they need to be standardized, so they should be in compliance with specific standards. Like I can give you the American or European format. The data should be in the same format, so the names should be basically the same, while the spelling of the same city or town should be the same, or the name of the same drug should be the same, so that we could have a clear understanding that we're talking about the same drug. So that's data standardization. Data standardization also means use of different reference sources. Well, as for pharmacovigilance, I can give you an interesting example of collecting big data and their structuring. Here we use MEDRA reference system, and that's a clear sign that the data will be standardized and structured. Also, data curation is another interesting moment. So we should monitor data on a regular basis, because these data are not intact. New information will be added, and that's an ongoing process. So what is meant by data curation? That means cleaning out data, normalization, and standardization. Again, an example with pharmacovigilance. Pharmacovigilance data existed due to data curation. The next definition, or rather definitions, relate to working with data, and that's the neural linguistic programming. Well, so we use this term NLP. Well, should not be confused with NLP of the 1990s, when we had the pseudo scientific theory of manipulation. When NLP was used, that's a totally different thing. That was natural language processing. Natural language processing is used for structuring of oral or written discourse, so that the machine could process it. Like when you call a bank and a robot response, well, there is this NLP process in medicine. There is a lot of systems like that to process a written discourse, and a special algorithm is used here. First, well, this source is being determined. To what extent, for example, this source is significant, whether it's the scientific article or information from social media. The weight of this information will be different, and this is taken into account while processing information. Then we classify data, so we determine what type of data this is, whether it's this is information about the drug or disease or adverse event. And then, well, tags are put on all this to develop the structure of a document. So that's what we can say about this process. Artificial intelligence, well, there is no exact definition of what artificial intelligence is all about, but intuitively, we can say that we try to mimic human intellect. In other words, AI is a robot that can think like a person. We haven't created this robot fully, but there are just some segments of the robot. Artificial intelligence is a combination of neural networks. So each neural network has been developed to perform a specific task, and a combination of these networks forms artificial intelligence. So you can see the neural network, and it consists of several layers. The first layers is information input, and then there are different nodes in this neural network, and each node is quite simple. There is the algebraic formula or some statistical algorithm. There might be different nodes. You can add nodes, you can remove nodes, but the most important thing is to determine the weight of each node to make specific conclusions. And then we can make one or two conclusions, well, as far as each network is concerned. And this network should always be fed with information. The network should get data from the real world. The network processes this data, comes up with a conclusion, and at the end, an analyst or maybe another network or a person corrects these conclusions and changes the location of these nodes. The network learns. That's what we call machine learning. In order to, in order for this network to learn better, more and more data are needed. And in this case, we can have a better output. In the end, Google Lab is a very interesting example. Well, Google carries out a lot of experiments with neural networks, like find a cat in the neural network, but without telling what is meant by a cat. Finally, the neural network learned how to find cats in the neural network. So that was terminology and definitions. Now I have just a couple of minutes how the system is being used. I like this tree. The roots are the data, the stem are the technologies, and you can see the fruits of this tree. These are the results that we obtain. And it's nice that you take a picture of this tree. It's not mine, but it reflects the real situation. Naturally, in each process, you should collect data, process them to use specific IT applications so that doctors and the researchers could use the results of this data. These are the data sources. And just as an example of pharmacovigilance, I like pharmacovigilance very much because here you can see the process of structuring of unstructured data in pharmacovigilance everywhere in Russia and globally. There are lots of IT technologies introduced, allowing us to structure data at the early stages. If you look at this picture, well, the vertical orange column, well, that's sources of data. The white column, well, that's basically market authorization holders. And in Russia, they are responsible for providing all the data to regulatory bodies. So market authorization holder collects all this data and then sends this data in the E form to regulators. They can do it by using Flex databases, our company, and the regulator gets this data in the E form. Well, then the blue field, that's the regulators. They are working on the national and supranational levels. National regulators have their database, for example, databases of the Ministry of Health, and usually in Russia, that's the Russian Health Care Surveillance agency. They collect all the data, and the data then are being provided to the Ministry of Health. In the European Union, each country has the national database, and the information will be sent to Eurovigilance or Euromed. In the United States, that's fair for vaccines, and as for all this data, they are also being provided to VG base at the World Health Organization, and at VG base they start looking for signals because that's the largest mass of data. So VG base has the largest sampling. So that was a very good example, which I like very much indeed. And just during the last minute, I'd like to say a few words about the limitations of RWD and a few words about the challenges we're facing. Naturally, big data are not structured, so you should know how to work with them. We don't have enough experience for working with this data. That is why regulators are very concerned when they get this data in the e-form, but soon algorithms will be improved, and naturally it will be much easier to work with this RWD data. There are also confounding factors, bias, well, and other problems, like if you want to achieve some particular goal in data mining, well, we can use the data to make a specific conclusion. So that's also one of the limitations. Well, in general, that's what I wanted to tell you, but the main message is that you should know all these IT approaches and the basic definitions that we've been using for 2 years. And that is it. Thank you very much.